Hi, I'm John Paulraj, and in this video, we will continue to solve question number 2 from paper 3, May 2025, time zone 3 for IB Mathematics, applications and interpretations. Let's get started. One of the main difficulties in meeting the European Union's target is the provision of sufficient public charging points. Okay, the European Union estimates that 80% of car owners will be able to charge their cars at home, and the remaining 20% will require public charging points. This is their estimation, by the way. It is planned to have one public charging point for every 10 cars that require them. Now, this is important. Understand what's happening. 80% of car owners will be able to charge their cars at home. The remaining 20% are the ones who need public charging points. This is the estimation by the European Union, and they said they are planning to have one public charging point for every 10 cars. One for every 10, 10 for every 100, that's like 10%, okay? So the idea is use George's model to find an expression for the total number of public charging points required at time t. So we want to find an expression. The model is already given, so basically it's 0.2 times 0.1, okay? So this expression basically this expression that we have with the values of c and k that was found out, okay, that's the expression, but we need that's going to be applied to 20% only of the number, okay, because only 20% is required, and the number of charging points, because we are saying to find the total number, expression for the total number of charging points is going to be 10% of that number. So what are we talking about is this particular expression. You recall this expression with this particular expression, okay, with the c and k. All right, so I'm going to do it here, g to h, and so we say n is 3101 plus, got this expression here, 2450 e to the power of a minus 0.458 t. All right, now this expression needs we need to put that thing, but remember the words are important how we write, okay? So we can use expression and say that required number of public charging points, okay, so at time t. So we can write it down, therefore required number of public charging points is basically 0.2 times a 0.1 of the value of n. Okay, so this is going to give us 0.2 times a 0.1 times that 310. Remember, that's actually in millions, okay? And so in the denominator we've got 1 plus 2450 e to the power of minus 0.458 t. We can simplify that numerator, okay, using GDC. Okay, here we go. I'll need to get my cursor here first of all. Okay, clear this, and then I say, okay, 0.2 times 0.1. You might be wondering, why is he multiplying these two numbers with that, man? 310. Why doesn't he simply do it? I'm making a lot of errors. 6.2, let's just check that. Okay, it's 6.2. All right, so we got 6.2 in the numerator. Let's just bring that thing down here. So we say 6.2 over 1 plus 2450 e to the power of negative 0.458 t. This is the number of required number of public charging points, okay? So we can write down number of public charging points, okay? All right, next one is 2i. At the end of 2020, there were 0.22 million public charging points in the European Union, and at the end of 2022, there were 0.54 million, okay? At the end of 2020, 0.22 million charging points, and at the end of 2022, there were 0.54 million charging points. Find the average number of public charging points installed per year during this period. Just 1 point, okay? So it's basically, just like finding the slope. So I have to scroll down all the way. Can I just go across? Yeah, maybe that's a better idea. Just go across and see whether I can just go there. So this is 2I, and we can write down required average. That's a nice word to keep in mind. Required average is basically the two values that we have, 0.54 and 0.22, and just divided by 2, okay, because it's across 2 years. So 0.54 minus 0.22 divided by 2. Again, show the substitution, and then using a GDC, make sure you write it down using GDC, okay? And you can come to the calculator. Again, let's just quickly get this thing out of the way. Get the, and this is 0.54 minus 0.22, whole thing divided by 2. And hit enter, and we got 0.16. Let me check the digits again. Yeah, 0.16. This is the average. So this is like saying million charging points. Am I showing what I'm writing? No. Charging points per year. Okay, at this instant, at that instant, at the end of, because I think it was something like that they said, right? During this period, you know, what was the average number of public charging points installed per year? Okay, so required average charging points per year. Okay, cool. That's 2I. Now what's 2J? Okay, that's George assumes that the number of public charging points will continue to increase linearly. That means at the same rate, okay, at the same rate until 2035. So George is assuming that, you know, that rate of increases will be the same. Determine the value of t greater than or equal to 5, at which the number of charging points will first be insufficient to meet the demand, okay, and it's for 6 points, and hence the year in which this is going to occur. The year in which this is going to occur. So the value of t we want to find out, but first we want to find out the number of charging points, okay, in terms of t. We need to do that, and to make use, we can make use of this, the fact that, you know, it's increasing at the same rate, and the rate is this. Remember, we already found that, right? In fact, those two values we can use, and we can just say that this is 2J, expression for number of charging points. That's what we want to find out, and that will be in terms of t, okay, and we have these values, but you know what, this 2022 and 2020 in terms of, remember, t is greater than or equal to 5, okay, we are calculating t, this is the one, right? 2020 is 5, can you see that? The value of t is 5, and so 2022 should be 7, okay, 22, 7, okay, so 5 and 7, so 2020 was 0.22, so we can write down that at 5 it's 0.22 millions, and at 7, at t equals 7, that is, you have 0.54 million, okay, have I copied it down correctly? Okay, cool. Then we can use 2-point form, any form, okay, you can find, because the slope is already there, right? We have that slope. You can use any of these points, okay? So let's just use the point slope form, any of these 2 points, because it's a linear. So let's just call this n, all right? And then we can say n must be equal to n minus, take 0.22 is equal to that slope that we found as 0.16, and t minus and 5. Okay, I hope this is clear. This is the point slope form we're just using. You could use any point, I just use this point, okay, and n we have already defined, okay. Any new letter variable that you introduce, make sure that you specify what that is, okay. So there we go, we can just simplify this as n equals 0.16t minus 0.16 times of 5, all right, and plus a 0.22. Okay, so let's just simplify this thing. Going back to the calculator again, 0.16 is there, right? I can multiply this by a 5 and say that value is 0.8. Is that correct? Yeah, and so that has to be with a negative sign, by the way. Okay, so negative of that term, and with a 0.22, that is going to be negative 0.58. Okay, I hope that is clear. And so we can say this expression out here n is 0.16t minus 0.58. So this is an expression for the number of charging points. So now we want to find the value of t when the capital N, and we're not talking about this expression, okay, not this one, okay. This is general. I'm looking at the one which was that 20%, this one, okay, this particular one. When is this expression greater than the one that we just found out? 6.2 over 1 plus 2450 e to the power of negative 0.45t, okay? When is that expression? So let me write it down here. We want to find the value of t, when 6.2 over 1 plus 2450 e to the power of a negative 0.458t is greater than 0.16t minus 0.58. I want to make sure that I've copied it down correctly, okay? 0.16t minus 0.458, 6.22450, and have I copied it down correctly? It's 2450. Yes, I've got that thing. Now this is something that I've been advising. Please check. Sometimes even copying down things, we do make errors. I have made a lot of errors, okay? Now, how are we going to do this? We're going to use the graphing calculator. We're going to use a graphical solution. But as I've said in my earlier videos also, whenever you use the graphing method or the solution obtained using the graphical method, you need to sketch the graph, okay? So I'm going to use the phrase using GDC, and you need to show, this is considered as working, eh? Sketch the graph. I will show you how to use the graphing calculator, but this part you got to do it. This is considered as working, okay? So whatever you see in the calculator, the graphical solution, make sure that you sketch the graph. That is going to be called as working. Now, when you're entering this onto the graphing calculator, you have to enter it with an X, okay? X and Y, only that will happen. T is not going to happen, but carefully enter this expression. When is this graph, the left-hand side graph, above the right-hand side graph, okay? So let's just jump to the calculator quickly, and we will add a graph page. Okay, add a graph page, and do we have something here? Let's just change that. We will change that to this expression. This is 6.2, and here I have 1 plus 2450 times e to the power of a negative 0.45, 0.458, and don't forget we're using X, okay? I'll just make sure that I have an into X. We need X, okay? And there's a graph that's drawn, and don't worry, it's kind of skewed right now. If you want, you can just change that to, I don't know, maybe 100. Let's see what the graph, ooh, okay, let's just make it maybe 50 and see. There you go, nice logistic graph. All right, so maybe you can even change that slightly to, I don't know, 10. There you go, that's nice. All right, now the next graph we will call not G, but we can change that to this one, okay? 0.16 X minus 0.58. So you can see what I'm doing, okay? So basically what I've done is that, you know, I've entered the exact expression, but in place of T, I've entered it as X, okay? The same thing that's there. So let's just go back to the calculator again. Now that we've got this function also, hit enter and it'll graph, okay? And we want to find the point of intersection, and remember we want to find out when is the blue graph going above, okay? Because that's the number of vehicles, whereas this one is a number of charging points, okay? So that means interpreting it as saying that when is it going to be insufficient, okay? When is the number of vehicles going to be more than the number of charging points, okay? So the red is the number of charging points, and we're looking for this point, okay? That's the value of X we want. So let's just come here, analyze graph, and we say we want the intersection point, and between these 2 points we'll find out the value of X is 15.2. I'm getting 15.2. That means the 16th year, right? 15 years after. So I just come back here and we can say using GDC, make sure you sketch the graph. I'm saying that again and again. So using GDC, the value of T is 15 15.2. 15.2. How do we interpret that? Remember, it's being calculated at the end of 2015. Remember, at the end of 2015, which is the beginning of 2016. Okay, so 2015, 15 years from there is 2030. So 2031, I think, okay, because what was the question? It says determine the value of t greater than or equal to 5, at which the number of charging points will first be insufficient to meet the demand, hence the year in which this occurs. So the value of t, we calculated that, right? We've calculated the value of t as 15.2, and then we can say during 2031. Remember, 15th year after 2015 is 2030, so it's 15.2. So during 2031, we got to write it in the context. The number of charging points will be insufficient. How do they say? Insufficient to meet that one will be insufficient to meet the demands. Cool. So that completes this question, and if you've been following this video, you probably noticed how many errors happened, okay? And this is what we call silly mistakes. If there's something that I have to take away, reflect from this particular video, not just this one, I think the last couple of videos on this particular question, there's a number of errors that I made in just copying. All right, so hopefully from my mistakes you can learn, and hopefully you can comment and let me know how to overcome this. My reflections on how to avoid silly mistakes may be the topic of one of the videos that I have to look at, okay, how to avoid that. But definitely I think one learning thing from this paper that I've solved is check what you write. Check what you write again and again and again. Okay, so that's all that the time that we have for this particular video. If you found this video useful, please make sure that you like, share this video with somebody, and subscribe to my channel. If you visit my channel, there are several other videos on my channel. Do check them out. And if you have any topic, any concept, anything that you want explained, do let me know in the comments and I will make a video for you.